Olá, boa tarde. Bem-vindos a mais uma sessão do AI Business Hub pelo ISCTE Executive Education. Esta é a nossa terceira sessão e agradeço de facto todo o apoio que tem ocorrido ao longo destas diversas sessões e todas as mensagens que temos recebido de encorajamento e de desenvolvimento desta iniciativa. O meu nome é Luís Felipe e sou consultor para a área de inteligência artificial do Business Hub e estamos neste momento ao vivo com o meu colega também, Bernardo Pinto, que faz a coordenação, e a nossa sessão de hoje vai ser dedicada à explicação elementar e simples de o que é a inteligência artificial, em palavras simples, e como é que as empresas podem beneficiar disto. O AI Business Hub é uma organização nacional e internacional, portanto temos membros quer de Portugal, quer do estrangeiro, e neste caso até temos uma situação mista, em que esta empresa designada por Prophecy Labs tem o seu fundador, embora seja polaco, vive em Portugal, e tem os membros da sua equipa dispersos pela Europa, o Vostec. Esta sessão vai ser em inglês, as sessões anteriores fizemos em português, foi com empresas nacionais, esta sessão vai ser em inglês, e o nosso colega Vostec, eu vou passar a anunciar e dar alguma ideia do qual o papel e da experiência de Vostec. So, I'll switch to English in this moment. So, Vostec, welcome to the webinars of AI Business Hub. Very welcome. Thank you for joining us. And I would like to give you some words about yourself before I switch to our colleague Bernardo Pinto, who will give also an introduction on the scope of AI Business Hub. So you, Vostec, you are an expert on artificial intelligence. You did your master's and PhD in artificial intelligence. What could be best than be a founder of a company that really deals with artificial intelligence? So you linked your theory into practical stuff, and you start doing business on this with this subject, which is very good. Congratulations. And this is a good example for the Portuguese small and medium companies to feel that you don't need to apply artificial intelligence. You don't need to be a huge company. It can be a smaller company, and you can start taking advantage of this new approach. I will hand over, before I hand over my word to you, Bernardo will give also some words, what is about our business hub and how they started, and what is the scope that we are covering, and what we are willing to achieve with this platform of knowledge and people. Thank you very much once more for attending our third webinar. Please, Bernardo, please go ahead and give us some words to the audience.
Okay, Luis, thank you very much for your words. Thank you for everybody that is attending the session, and a special thanks to Vostec who are speaking today about a very interesting subject, which is the application of AI. What are the main concepts of the theory, and the main concerns in the implementation of AI in real cases. But first of all, I want to stress again the idea behind the Business Hub, which is a basic idea to join everybody that has interest in this team, every stakeholder that is providing solutions, that is looking for solutions for government, for policy makers, everybody that has any particular interest in this subject may join the AI Business Hub. We have people from academy, we have people from startups, we have people from big companies. So everybody is very welcome. And since the very beginning of this project, I'm very happy about the suggestions, the ideas, the welcomes. So we start with this kind of webinars because of the COVID situation, but we are moving to other approaches to bring this technology to our companies, to take the technology more democratic for people that want to introduce these solutions in their environment. So once again, thank you very much. Luis, you are going now to pass to Vostec directly, or you want to say something?
I will hand over to Vostec. So he will give us a presentation around roughly 35 minutes. So, and then we'll have, after his presentation, the audience has the opportunity to raise raise some questions. So please be prepared and be attentive to his presentation, because you'll have the opportunity to ask real-time questions, but as well, if you have any further questions that came up after this presentation, first you can send us an email, or if you'd like to see again his presentation, this will be available, remains available on YouTube, so you can watch it again and put us the questions afterwards. So Wojtek, I'll hand over to you. Thank you very much, and welcome, and all the best for your messages to us.
Thanks a lot, Luis, for the introduction. Now let's get going with the actual presentation. So I'm going to start sharing my screen. Luis, please confirm that now you can see the presentation.
Yes.
Perfect. So what we're going to talk about today is how to make sure that your AI is not only, research and prototype, but actually brings real value to your business or your organization. So let's see what we have today on the agenda. First of all, we're going to talk about what is AI. You've heard for sure a lot of buzzwords regarding AI, machine learning, etc., etc. I'll explain briefly what's the relationship between them and what it's all about. Then, to ground ourselves a bit more in reality, I'm going to discuss a short case study that we did at Prophecy Labs, a project that we implemented at a big enterprise. What was the reason, what was the goal, and what was the impact. That's going to take around 5 minutes. Then we'll have types and phases of an AI project. So basically, how can we basically classify the types and the phases that an AI project can have. This is going to be very useful in the next stage when we will actually try to see how can you identify relevant and useful AI use cases at your company or your organization, and how to make sure to pick the ones that actually make the most sense, and to, so to speak, go for the low-hanging fruits when you can have maximal impact with minimum effort and expense. And then at the end, we'll have a short discussion about how we can make AI projects successful and what are the key components to success of an AI project. So without further ado, what is AI? So first, let's talk about the levels of AI. I'm quite sure you've heard the terms artificial intelligence, and some of you might have heard the term artificial general intelligence and artificial narrow intelligence. So to explain a bit, artificial narrow intelligence is everything we have today. Things like Alexa or Siri or general predictive analytics are considered artificial narrow intelligence. It's everything when you basically have AI do one thing and one thing well, but it's not portable. You cannot make Siri cook dinner for you or predict the next stock market crash. They're only doing one thing and one thing only. That's where we are now, and that's where we'll be technology-wise in the coming decades, maybe even centuries. Now, in some science fiction, you see general artificial intelligence when basically AI is as smart or a bit smarter than a human. It can do everything. And then we have artificial superintelligence when AI is so much smarter than a human that we're basically like ants to them. This is pure science fiction, and it will remain so for the foreseeable future. Now, moving on to a bit more background of AI, let's talk about the taxonomy. So you know the terms artificial intelligence, machine learning, and deep learning. What is the difference? So AI the term has been coined in the 1950s, so a while ago already. And what it's all about is basically it's engineering and making intelligent machines and programs, something that involves solving complex tasks. So not something that can be very easily mechanized. Now, stemming from that, we have machine learning. Machine learning is a subset of artificial intelligence, and it concerns all the algorithms that can learn or find patterns in the data without being explicitly programmed. And deep learning is nothing more than just a subset of machine learning that uses a very specific type of algorithms called deep neural networks that imitate human brain to a certain very small extent. Yeah, to just bring this point home is that these terms are not different, they are just subsets of each other. So yeah, in that sense, they are of course different. So again, AI is the widest term, and it concerns all the systems and algorithms that deal with solving complex problems that generally are done by humans. And machine learning is a subset of AI that can identify patterns in the data and in the world and rules without being explicitly programmed to find, to given these rules, so it can find it themselves. And then deep learning, they use deep neural networks, and it's also a way to find patterns in data. Another important distinction is business intelligence versus artificial intelligence. The way we like to look at it is business intelligence describes what has happened in the past and what is happening now. So it's very descriptive. It doesn't tell you what's going to happen, but it gives you an overview of what's going on right now. And then artificial intelligence generally talks about the future or the unknowns. So it's prescriptive. It tells you what to do or what is going to happen or what has happened if we have incomplete information about it. That is quite important difference, is that BI might be actionable if you develop some processes. AI can be directly actionable, is that it predicts something and it can act on it. And because of that, we believe that artificial intelligence will, in the end, have much bigger impact than whatever impact business intelligence had so far. Now, another interesting topic and a concept that is related to AI is, of course, data science. And what data science is basically everything that encompasses and talks about and concerns working with data and discovering patterns in data. So it definitely encompasses fully machine learning, because machine learning is finding patterns with in data without being explicitly programmed. It also concerns everything that has to do with processing data, so parts of data engineering. And then you want to, once you have the machine learning model that works, you want to extract this knowledge and present it somehow to business stakeholders, to users, to whoever your business application is aimed at. And for that, we need business intelligence. So we need a way to visualize and present data. And then, of course, you have everything that's in between, everything that you need to go from getting the data, collecting the data, identifying what is the use case, how to make it worthwhile, and how to make it impactful, then developing the model, and then presenting it. If you put it all together, that's what we generally call data science. So what's a typical data scientist persona or ideal data scientist skill set? So basically, data scientist is someone who knows maths and statistics better than any programmer, and programming better than any statistician. And that is a saying that's been around for a while, and I find it extremely true, is that you really need a bit of both worlds, but you don't need to be an amazing programmer to be a great data scientist. You just need to be good enough. And what's also important is you need to have a bit of, ideally more than a bit of domain knowledge, because this really impacts how you look at the problem and whether you can find things that are actually relevant to a given business or given organization, or generally even a team. So knowing a bit of what the data that you're analyzing is about is a huge help. So to summarize our first part of this webinar, what are the takeaway points here? AI is the encompassing term for basically everything else. Machine learning is about finding patterns and learning specific tasks without being explicitly programmed to do so. Deep learning is just a subset of that. From purely business perspective, the only reason to really talk about deep learning as a separate thing from machine learning is if you are concerned about performance. So deep learning generally takes much more computing power than normal machine learning techniques, and it works better with the data like images or text. And now when it comes to the roles, we have the data scientist at the forefront. We have a data engineer, who's a guy that basically stays in the background and makes sure that everything runs correctly and everything is processed correctly. And normal IT, I think the closest counterpart would be a DevOps guy. And then we have a data analyst or a BI expert who makes sure that the insights are properly communicated to business stakeholders. Now let's talk about something less abstract and very real and hands-on. So we're going to talk about the case study that we did at Prophecy Labs for a company called Drive. Drive is a big NASDAQ listed car parts manufacturer And what they do, part of their offering is, of course, new car parts. And what's interesting is that they make 20 new car parts every day, and they need to display it to potential customers somehow. So they have an online catalog. And in this catalog, they came up with a very smart idea of doing 3D images, so you can rotate stuff and see exactly how it looks from every angle. To do that, they need 24 images per every car part. And if you want to create really nice visualization for that, you need to remove the background. Before we came in, there was a team of 7 graphic designers or Photoshop experts who were doing that full time, just removing background from every image. And because you see that it's a lot of images, the images were very high resolution, 4000 by 6000 pixels. So it took a lot of time, which also means that it cost a lot of money. And because this is a rather unfulfilling job, they were faced with extremely high churn rate of the employees. And again, because it's a very unfulfilling job, the quality becomes lower and lower in time, because who can keep on doing the same thing over and over again? So that was basically the problem, and they wanted to automate this process. And how do we go about it? So basically, first we start with coming up with the idea of what is the actual problem? Is this problem real? Is this problem solvable by AI? Is this problem impactful? That's something we discussed during our discovery session. And then if we decide that it all makes sense and the clients are happy with the idea, then we move forward and we build a very small proof of concept, just to show that it's all feasible. It can be done. It can be done with the constraints and the data we have. After we complete our POC, we move into the build phase. The build phase is all about making sure that the solution is not only feasible and okay-ish, but actually good enough for the business context and for the problem at hand. So we do much deeper research there. We prototype a lot. And once we have something that we believe is good enough and the client believes that it's also good enough, then we package it and then we put it in production. It doesn't need to be completely robust or scalable. What matters is that it already delivers business value as soon as possible. So the moment when it's better than whatever they had before, we put it in production, it starts working, they can experiment with it, and then we go from there. And then the last phase of the small cycle is the automate phase, where we make sure that things are indeed scalable, robust, and that can be easily or are integrated in their IT infrastructure. After that, we continue with maintenance, because as I will mention later, AI will not stay performant over time and the performance will degrade. So with that approach, we managed to solve the problem, of course, otherwise I wouldn't be talking about it here. And we managed to reduce the time to clean a single image from around 10 to 15 minutes to 0.7 seconds. We got cleaning pixel accuracy, so how many pixels were correctly classified as background or car part, to be above 99%. I think it was significantly above 99%. And the bottom line, the real business impact is we managed to save more than 11,000 man hours per year. So basically, this team of 7 could be redirected to more productive pursuits, and the process that was soul destroying for them was completely automated. So that's what we did. And how fast? So basically, our typical pipeline is that we start with the exploration, so the proof of concept and small research. That's going to take generally 3 weeks. After that, we see that the POC is there. We can show the client that the problem is feasible. It can be completed. We have the idea how to do it. Then we take between 2 and 4 months to actually deliver the solution. So we build the MVP, make sure it's good enough that the machine learning model itself is robust, if not even the solution around it. We package it, and then we ship it. So now let's talk about some AI use cases. How do we structure a kind of use case discovery process, and what types of use cases you can even have? So the way we look at structuring use cases in a company is generally we look at what departments are in a given enterprise. So you can have finance, sales, marketing, HR, operations, retentions, whatnot. Then we have use cases, and we like to basically split the use cases into 3 types: automation, optimization, and prediction. I'll talk about it a bit more in detail later on. And then from a bit more technical perspective, we look at what kind of data is available, what kind of data might be needed to solve a given use case. So to go back to the previous example, we needed images, obviously. If you talk about something like churn prediction, so predicting whether somebody's gonna cease to be your client and it's gonna change providers, for example, in telecoms, we would mostly work with structured data. So basically, what kind of person is that, their purchase history, how long they've been a client, etc., etc. So yeah, let's talk about the 3 types of use cases that we generally like to stick to. So automation, what automation is about? Automation is where you want to replace or augment, most of the time a bit of both, human work. And to give you an example, you might know a website called remove.bg, where basically you put a picture of a person or a car and it removes the background automatically. It's kind of similar to what we did at Drive. That's a typical use case of automation. You had something that was done over and over again, very manual, laborious process, and now it's automated. And I think might be if you want to process some documents and you need to process the same document over and over again, in insurance, that would be insurance claims, when they need to provide certain document that describes what has happened. You have a human doing that, you can just automate it. Then optimization. So here we're talking about optimizing various business processes. It might be things like scheduling, logistics, complex manufacturing stuff, where you basically have something that's a process that's very complex and you don't see the easy route to make it as efficient as possible. That's something that can, of course, we can improve the efficiency of that. And then we use either techniques from operations research, and then later on, we also include data-driven techniques to really bring it to the next level. An example here would be vehicle routing. So basically, we can talk about something like Uber Eats. We need to deliver multiple packages from multiple starting points to multiple endpoints, and we have lots of drivers. How do we minimize the total cost of the company in terms of labor, fuel, number of vehicles, and customer satisfaction? It's a very complex thing, but we can make it more optimized than just human trying to come up with a solution. And then the prediction is predicting everything that will influence your business. It might be demand, it might be churn, it might be some unusual failure in your logistic system that just happens and would strongly influence your business. Example here from Uber, predicting the number of completed trips per day so they can price better, and then you have things like surge pricing or discounts, which basically makes sure that in the end their cash flow is better because their lows are not as low and they really make as much money as possible during the highs. So now that brings us to our 4th talking point during this webinar, and this is how to identify AI use cases. This is the time we're going to spend a bit of time on that. So first of all, when we want to identify AI use cases, where do we look? Where do we even start? And there's basically 4 ways you can look at the business in order to identify good AI use cases, and that is look for business processes, look at the departments, look at the data, and look at the customer journey, how the customer feels. This is the most important part of every business, so you always need to look at the customer. So let's start with the first point, the business processes. So the first question you should ask when you try to identify use cases, looking at business processes, is that what are the parts of your business and your processes where you would benefit from knowing the future? And here again, we can use the churn example. If you knew that this particular client considers heavily switching to an alternative, maybe you would do something to stop him. Maybe you would give him a discount. Maybe you would just call him and follow up and make sure that he's involved in the company and he stays a customer. Maybe if you have a hotel chain, you would like to know the future demand so you can plan the staffing and also adjust prices. So anywhere when you would like to know the future, and if you knew that it would improve your business, which is basically everywhere, you can basically have a prediction use case. Then let's look at the business processes where things are done over and over again. And as you probably guessed by now, this is typical automation use case, when instead of doing that over and over again, we just leave it to the machine to do it for us. And then the last way of looking at business processes that help us find use cases is look at the parts that are very complex. And here we could optimize these complex processes to make them more and more efficient, and hopefully at the same time more robust. Now, to move on to the departments, sometimes there's a big knowledge gap between departments, especially in bigger organizations, bigger enterprises, and then they don't know something they would like to know, or even more often, just something that they would like to know and they don't. If you look at, yeah, let's just stick to retention again. They would like to know what's the main cause of churn, and right now, it might be hard to figure out. Of course, you have surveys. Some people answer that, but people that are generally unhappy when they leave, they don't leave feedback. But maybe you can look at the data to try to infer what are the most important things in general and in specific that cause people to leave. And that's a very useful piece of knowledge for the retention department. So good use case. Again, same thing. What work is repetitive? If you work in a bank, one of your major activities, or maybe the most important one, is giving out loans, and you need to approve loans. And when you approve loans, you need to review the application. And the applications look very similar. They're almost all the same type. Most of the answers are quite obvious. There are, of course, edge cases, but then let's maybe augment human analyst, and the cases where AI is very certain, just approve or disapprove of the loan. And in the cases where it's really an edge case, AI can still provide recommendations. So we can augment or replace repetitive work. And then when you look at departments, again, in the big organizations, it's oftentimes that it doesn't, there are some things that do not really work between departments. Maybe the information flow is bad. Maybe there's very complex planning that spans multiple departments, but they have misaligned incentives. They are trying to achieve one thing. Here, for example, what you could see is that if sales is really good at finding new customers, but they tend to leave after a month or two, then it makes sense for sales to still keep on, doing marketing and trying to sign them up, because that's what they are incentivized to do. But on the company level, you're actually wasting money because their LTV is very low, and if you look at cost of acquisitions, then you're probably losing money on every single customer that joins in for a month and then leaves. And these are the things that if you had a general overview and you really took a data-driven approach, you could see and try to optimize. Now let's look at the data. What would you like to know ahead of time that you're tracking now? The tracking now part is very important because in vast majority of algorithms, what's needed is training set. And basically that means that you need to know what has happened and something that you already have. And based on that, you try to infer future behavior of the same thing. So in the case of demand prediction, you need to know past demand and things that are associated with demand, or you believe they are associated with demand, to try to predict demand in the future based on the same things. So if you're tracking demand, if you're tracking sales, of course you're tracking sales. And if you're tracking a few more things like customer signups, you would like to know how the customer signups will affect your total revenue, for example. And that's an AI use case. Here, what are the data points that are input manually? Maybe there is a form that your analysts need to fill in after they receive a complaint. Maybe let's extract this information from the complaint automatically, fill in the form, put it in the database. It's less work for them. It saves you money. Save their time, and by their saving time, you save money. And the last way of looking at the data that could be useful for us is what if you could take a look at all the data you have at once? Is there anything that you imagine you could see that you don't see right now? Maybe there's some very complex relationship that you'd be able to see, and you already have some idea, but like it's not possible for a human to actually see whether that's real or not. Well, one really nice thing about machine learning is that the algorithms can process even hundreds or even thousands of the information points about a person or a product or an event at the same time, and they can try to find relationships between them. So they literally look at all your data if you give the data at once and see what are the patterns. And now the last, probably the most important part of what we look at is the customer. And let's start with the funnel. Your marketing and sales funnel, of course, has stages. And then imagine that you could know what impacts whether somebody moves from one stage to the other. Then you could optimize that, improve your conversion rates, maybe adjust marketing spending or adjust your sales force so that you can really grow at maximum rate. And yeah, that's basically what most businesses are about, of putting people in the funnel and then processing and then qualifying them in a way that basically maximizes revenue and minimizes costs. And if you can look at what are basically the propensity or chance that it moves towards the next stage, that gives you a huge edge, because then you can optimize that. And then let's talk about the last part of the customer journey before they become a client, which is the first purchase. What's hard, what's annoying? If they need to manually fill a lot of data before they can make a purchase, that might be a turnoff. When you look at e-commerce, cart abandonment is a huge issue because people are basically unwilling to put in the last piece of information and they would rather look somewhere else. And let's try to streamline that. If there's something that instead of giving, maybe you work in finance and you need to verify the identity, then instead of having customer manually input all the information on your ID, he can just take a picture, quick snap, and then it automatically is filled in and he just verifies that the information is correct. That makes the purchase process much more pleasant and should increase your conversion. And then the last thing is that imagine that you knew everything about your customers. You could improve your marketing, you could improve your pricing, you could improve your retention, you could basically improve everything that has to do with your customers. And maybe there's already lots of data that you're collecting about the customers, but you're not processing it, you're not drawing insights. Maybe you can use machine learning to automatically find the most relevant segments instead of trying to do it in a semi-manual way, and what really makes them tick. What is the best way of reaching out to given segments, and then even to every single individual. So that's another way at looking at customers. Yeah, maybe now it's time to take a small break and take some questions from the audience if we have anything there, Luis.
Yeah, Wojtek, thank you very much for the presentation for the time being. I think this has been quite comprehensive. What you have given to now, on not only from the perspective of different market sectors, as well from the different organizations within a certain company or organization. But it draws me, it makes me think that there are several angles to attack and to use the artificial intelligence approach. First, one thing, you from the consulting perspective, and thinking that artificial intelligence crosses different market sectors, which one do you think is more mature or might be more ready to and will benefit more from using the artificial intelligence? This is one question. And from that perspective, on this market segment as well, there's a second question. Since this crosses all the departments of a certain company, where do you think you should start on a certain company to address and to approach or to automate or to use robots or bots or structure data from one certain department, from that from that sector, or that couple of sectors that you think are more jazzy nowadays, that are more ready and more that can benefit more from the artificial intelligence approach? What is your view on this?
Yeah, so I think that's a very good question. And the way I see it is that what benefits and the organization that benefit from AI are the most are the really big ones. So basically, value from AI comes from scale. And the general improvements that AI brings are relative to the size of the company. So if we take something like Nosh, Nosh is a huge company, and if they could improve their retention or revenue or conversion rate by 3%, that's a lot of money. But if you have your store next door and they improve their revenue by 3%, they have so much room to grow, and there's so many more impactful ways to make their business better that doesn't make sense. So I would say the first most important thing is really the scale. And if you have something that even if you increase it by a relatively small amount, 5, 10, 15, maybe 3%, it's already impactful. That's really a good place to get started. Another one that's kind of a big factor in AI readiness is whether you already process and collect data, and ideally if you already have a BI department, or at least few people that do business intelligence. First thing of trying to predict what's going to happen in the future is knowing what has happened so far. So then I would say sectors that were always trying to maximize their efficiency, so insurance, banking, telecom, energy. Yeah, I would name that they were always a bit advanced when it comes to trying to figure out what's going on in the market. They were using data for that, and some of them already have quite a few models implemented in production when it comes to machine learning, and I think they're ones that are basically making the most money out of AI and making AI the most impactful in their businesses. And to answer the second part of your question, when it comes to trying to figure out where to start, I would say you always need to look at the impact and at the cost at the same time. So look at what's very painful for you. Try to see if that could be an AI use case. And if yes, contact experts to see how long it's going to take, is it going to be expensive or not. And then you can prioritize based on that, based on urgency, based on impact, and based on feasibility, basically.
Okay, thank you very much, Forstek. I think it was a good overview on the approach that the way you see, and that you have been selecting your cases, and where you have been seeing on the market those opportunities. Okay, please go ahead on your extra chapter. We'll still have some minutes, not that long. Time is running quite fast, so let's have more.
Okay, then let's get to it.
Yeah, let's go ahead.
So the last part is how to make AI projects successful and what are the key components here. So let's start with an overview. What's like basically the biggest part of an AI project is defining really clearly what are the goals. And let's talk about churn again. The goal is not to really make a churn model. This is the way we achieve a goal. And the goal here would be to reduce churn, because that is basically what's gonna, make the project worthwhile. And then once we really define the goal as in what we want to achieve by using AI, the goal should never be to use AI for the sake of AI. We should always develop the metrics. And here I'm mostly talking about the metrics from the business perspective. So basically, if we can link the impact of an AI project to bottom line, so basically to how many thousands or hopefully millions of euros you make or save with AI, this is perfect metric. We just want to track that. For the case of loan default prediction and trying to predict whether somebody should be given a loan or not, this is possible because you basically take into account your risk, how much money you're making by giving loans, how much money you're losing by giving loans to people who default, and how much money you're losing by turning away people that would normally pay back the loan. You can calculate what is the impact of the model, and what is always important compared to what we have now. So we come to benchmarks. And to go back to an example of churn, you probably have someone trying to predict, or a team, or a very simple mathematical model, or even maybe more advanced statistical model that tries to predict who's going to churn. We take that as a benchmark. That's what we have now. That's what we're using. And then we see if we can improve on that and how much. And what's really important is that we cannot really consider performance of machine learning models in the void. There might be use cases where just being slightly better than random is more than good enough. That is exactly what we look for. For example, in stock market prediction, we just need to be reliably and robustly a bit better than random. And then there are some cases when the problem is generally simple and we really need to be almost perfect. To give you an example here, let's take a look at our case study. When you really needed to remove the background from images in an almost perfect way. If we did it in a way that is like okay-ish, it still looks terrible, still human needs to touch it. Then we need to look at, from a more technical perspective, the data access and storage. What's up with that? How do we make sure that we can integrate it? And then the last part is, once it's in production, how do we monitor and maintain models? So let's talk about our churn example. So people will stop being our customers. We need to identify which ones, we need to identify why, and how to retain them. This is basically what churn is about. So what's the goal here? The goal here is reduce churn. And this is the main primary goal. This is the only thing that in the end, bottom line, we care about. And how do we go about it? Well, one thing is to try to identify the segments that churn more often than others. Maybe then we adjust our marketing and our retention efforts in order to, on marketing side, target the segment less, and on the retention side to target the segment more. And then general main reasons to churn. Maybe the main reason that people churn is actually that the quality of customer service is not sufficient. Then segmentation would really help at trying to retain single customers with discounts. It's not going to help at all because they are churning because they cannot get the support they need. So these are the goals. Now, how do we measure whether the goals are achieved? So metrics, churn rate, as simple as that. And then when you look at another metric compared to the benchmark, we want to see what's the drop. If we drop from 20 to 15% in churn, that's really good progress. If you drop from 2% to 1%, that's also amazing. If we drop from 20 to 19, that is not as impressive, right? And in the end, the bottom line, what we try to get is euro retained per month, because people are not churning and we still have amazing recurring revenue. And the benchmark is just what we have now. If it beats what we have now, it's good enough. That's what we try to do normally. Data access and storage. So here we talk about things. How will the data ingestion look like? So a bit more technical. How will the humans interact with the churn model? For example, would they like to have everything automated in the retention department, that even the follow-up emails and discounts are decided automatically? Or they would like just to have a suggestion how the suggestion should look like? Should it be integrated in the CRM solution in the end? Should it be just a simple Excel file? What is the preferred and most optimal way of interacting with AI? Because in the end, humans always need to interact with AI in one way or the other, even if it's just outside facing. And probably the most technical question here is, what skills need to process all client data? If we only need to process tens or hundreds or low thousands of customers per day, the solution from engineering perspective is going to be completely different than if we work with high thousands or millions of customers in total. And then the last question is, how sensitive is the data? And this will also impact the architecture and the solution from engineering perspective. If the data is very sensitive, of course, everything needs to be done on premise, maybe on local cloud. If the data is not sensitive at all, then we can even use our cloud to develop and then deploy the solution. And then the last part, which right now I believe is quite, it's not talked about as much as it should be, which is what happens afterwards. Because imagine that you deploy this churn model and everything is going well. It's a great model. It saves you a lot of money. So you just let it run and it takes over more and more things and almost everything is automated. And then A few years down the line, you change your marketing strategy because it's a good idea and it works, and you actually have more clients, but you have more clients that are different than the clients you had before. And that means that the world changes. And because the world has changed and your business has changed, data has changed. And when the data changes, that means that AI models degrade over time. And what is that? Because the models are trained on a static data set that doesn't change. They learn patterns from there. They don't learn patterns necessarily. They should generalize, but they don't generalize infinitely good. There's always a limit to generalization. And if you have new kind of data set, the patterns there are going to be a bit different. So you will lose business value in the end. And it might even get so bad that instead of just losing what you gained with AI, you're losing more because things are so different. And for example, with churn, if you say that the most important part for churning is that they're receiving a digital invoice instead of a normal one, and that means that they are high churners, that makes sense. It's a good idea because maybe it's younger people that mostly work with digital invoices. But here, imagine that you actually change the way you do your business and you decide to go fully green and all invoices are now digital. Then your model is going to say everyone is churning. We need to stop all of them. Let's send emails and send discounts. And then you end up not only, not retaining people that you needed to, but you actually decrease your revenue because you give too many discounts. So we do not know why people are like the models are degrading. And to give a very specific example of the churn, something we based on a Belgian telecom, the biggest Belgian telecom, is that they have around 650 million in profit. Their churn rate is very low, 2.6%, and they have 2 million customers. They have already a churn model in production, it's working. And let's say that this model will decay 5% in a year. This would mean that their churn rate is gonna say jump to 2.87. That seems like almost nothing, right? 2.6, 2.87, same thing. The thing is that at this scale, they're losing almost 2 million a year. And that means that they lost 5,000 customers just because their model degraded a bit. So it's a huge issue, and we are developing and creating a product to solve that. So again, if you already have something that's in production and you find monitoring and maintenance important, also give me a call or reach out to me and we can talk.
Yeah. Okay, Wojtek.
Sorry, Luis.
Yeah, sorry, apologies. Yeah,
yes,
we have some questions popping up.
Now, I'm just gonna wrap up first. And things that I need to say here is that our course for AI for Business is sponsored and subsidized by European Union through Belgium, but it's the same EU, of course. And yeah, we're of course very happy to receive that. And we would very much appreciate if you scan this QR code right here. And there's going to be a survey day from SurveyMonkey. Also have the link here. If you could fill it in to give us some feedback how to make this better and what are the things you would expect from a thing like that, we would greatly appreciate that. And that is it now. Time for questions, Luis. You're muted. Luis, you are muted.
Thank you. Okay, thank you. Wojtek, meanwhile, we've got some questions from the audience, namely the concern with people on security. What do you have to say on people security, organization security, protection of data from virus and hackers? This is one of the questions. If you can say something, and then there is obviously in European Union there is this GDPR, GDPR protection, the law, the protection from hacking. And as well, there is also from the same person, there is a question about industrial maintenance. If you have an example of an application in AI for the industrial maintenance, this is from another one is that regarding data science strategy, if this is more applicable to ERP software or marketing CRM. I won't answer on your behalf. I could, but I mean, I'll give you the word on these three topics. If you could do
okay.
Quickly.
So yeah, let's start from the first one. So security and everything related to security and data security. Yeah, so that's a complex topic. And basically, the way we see it is that the more security is needed and the more sensitive the data is, in general, it's going to be that harder to develop stuff. But in the end, we can work with everything. So first of all, GDPR. Right now, the algorithms, the way we develop it, we can get an anonymized sample. And later on, as they go in production, it's actually quite easy to guarantee that not a single human actually sees the data, but it still goes through the model. Predictions are made on the data. The data is anonymized, and that makes it fully GDPR compliant. Now, when it comes to data, very sensitive data, so yeah, things like banking and even more so pharma and medicine and hospitals. What we work with, and that's something that you generally do at enterprise because they require that, is that we have a solution on premise, so we can develop software and deliver it on premise. So it's not even in their cloud if they really don't want it. And then that way the data never leaves the premises of a company. And then in the end, the security and making sure that the data is not stolen or hacked, it's fully within the enterprise's IT department. We are fully compliant with what they do. And that basically solves the problem. We generally try to avoid moving sensitive data outside. We're still a small company. We're doing our best, and we are staying always GDPR compliant. But when it comes to targeted hacker attacks, honestly, no experience with that. So if the data is sensitive, we just make sure it stays where it's safe, which is at the company's.
Thank you. The second one was about industrial maintenance. Do you have an example on application of AI?
So that's something we actually did a small project on in US. We worked for a wind farm manufacturer. So like they don't only produce wind turbines, they make the whole farms and basically sell wind farms around the world. And of course, the wind turbines need maintenance. And what we could do is basically, instead of the problem here is to give you a short overview, is that you don't want to maintain wind turbines during the times of high wind, because then you're losing more energy. So you want to do that. And also you want to maintain only when needed, because the wind turbines should be operating all the time, and maintenance actually takes a lot of time. It takes, I think, on average around 2 weeks. Don't quote me on that. I don't really remember. 2 weeks a year that you're losing money. So you want to maintain exactly when needed, because if you don't maintain early enough and often enough, that's a huge problem. So you want to minimize when you maintain and maintain exactly when needed. That's something we did. We predicted when anomalies will start happen before they become in any way dangerous. We predicted when they will happen and when you need to maintain to minimize the risk and maximize the uptime of a wind turbine.
That's a good example. Yeah, I think it's a really.
And there was a third question. Can you remind me of the
third question? Is about the data science, whether this is more applicable to ERP software or marketing CRM. Once you have ERP and marketing CRM, this data science, whether how you can introduce this to or replace it or yeah.
Yeah, so I see robotic process automation and yeah, sorry, before that ERP. And then CRM, I don't think CRMs will go away ever, because they help humans, right? But now some CRMs becoming slowly data-driven. Like I think in HubSpot, you can always get AI-driven, basically sales predictions. And I think this is just gonna continue like that. So you will have more of that and more of that. And at some point, human is gonna be more of a person that just handles the interaction, and all the admin stuff is done fully automatically with the help of AI. And then something I wanted to mention, like I started to say about robotic process automation, that it's a stopgap. This is something that I believe will go away, because right now robotic process automation is used to like move stuff, and that's why I thought about it in the context of CRM, is that sometimes you use ERP to basically move data from one place to another. But once this data process and data lakes are really set up properly, you can just move this fully into engineering and IT, and then let AI do the insight and pattern digging.
Okay. Just we still have 3 minutes, so one last question for that you might answer in 1 minute. I'll have two minutes afterwards because I'd like to announce the next session. One thing is that if I'm a company and I'm not sure whether I could use AI or not, how can you help me on that, or tell me whether it is usable or not, this AI approach? Can you tell me? And can you also guarantee and tell me that is this going to fail or not? Because we hear that many projects fail, or there is a lot of percentage. But now the situation is probably different. So in a minute, in a nutshell, can you give me in a minute what is your view on advice on this, on my company?
So projects can fail, and that's why we have the explore phase. If the project is going to fail, we want it to fail fast, so we don't lose time, we don't lose money. And that's how we basically, it's a feasibility study in a sense. We find early whether the project is feasible from a technical standpoint. And if it's feasible from a technical standpoint, another reason why projects fail is that the requirements are not clear, the goals are not clear, the metrics are not clear. And that's something we always make sure when we start the collaboration, that this is very well clarified and everyone is on the same page, so the expectations are properly managed. And how do we get started? Well, we talk to people that are willing to talk to us, and then we see what the problems are that they're having, what are the ideas for using AI, and we come up with something that has big impact and is easy to implement, especially in the beginning, to build trust and the relationship. And then we move forward and we move on to more and more ambitious examples and ambitious use cases.
Okay, thank you very much, Wojtek. It's all for the moment. We are getting close really to the time. We came to the time. We'll come back, probably people that have been attending will come back to you to learn more. We expect so, we believe so. And I'd like to thank you and to thank all the audience that have been watching this session. And I'd like to remind that within a week, we'll be back again. The AI Business Hub by Executive Education will come back on a subject, a touchy subject nowadays, which is healthcare. So we'll, our member from the AI Business Hub and NAI, we'll talk about the cases they have developed in Spain to fix some cases of healthcare process of healthcare in Spain with the help of AI. This is nowadays a subject of the day, and thank you very much once more. See you within a week. Thank you.
Thanks a lot, Luis.
Have a nice evening.
Thanks everyone for joining.
Thank you. Bye now.